And we have done distance and displacement in the motion.
Yes, sir.
And today we'll be going to discuss the graph. We have done the average. We have done the. Okay. So if I ask you a simple question here, that you know that speed is equals to distance upon time. I have taught you that Emma, do I have taught you the speed velocity, the scalar and vector quantity? The scalar and vector quantity do I have taught you? What is scalar quantity? What is vector quantity?
No, sir.
No, I have not taught you. What is scalar quantity? What is vector quantity? Let me explain. So there are some physical quantity that is going to have some specified direction. Okay. So scalar and vector quantities. What are scalar quantities? What are vector quantities? Let me explain. Scalar and vector quantities. There are two types of physical quantities that is going to. So what are physical quantities? First, let me explain you that physical quantities are those quantity that is used to measure something. Okay. Like for example, if you are moving a distance, then you will measure it in meters. So meter is a physical quantity. Okay. Like you have some mass, then you will measure it in weight in kilograms. Okay. So, and similarly, if you have some volume, you will measure it in liters. Okay. So we have, if you are moving for a particular speed, you will measure in meter per second. So that meter per second is a physical quantity. Okay. Got it? Kilogram is a physical quantity. So and if I'm saying that if I'm moving like this here and here, and if I am traveling at a speed of 20 kilometer per hour, but I don't have any direction. We only have the magnitude that is 20 kilometer per hour, but don't have the direction. But what if I'm moving in the north direction with a speed of 60 kilometer per hour? Now I have a direction and a magnitude. The magnitude is 60. Magnitude is 60 and the direction is north, towards north direction. Okay. So here there is no direction, but only magnitude. No direction, but only magnitude, Okay. And let's similarly, if I'm having that this is a force applied on the box, that I'm going to apply the force 10 Newton force on this box in the direction of that this is north, south, sorry, this is south, north, south, west, east. So I'm just applying the force towards the direction of east on this box. Okay. And another boy start applying the force of 2 Newton in this direction towards the. So I have magnitude and direction. Okay. But there are some physical quantities, like you are sitting in a room. You are sitting on a bed, okay, in a room, and you will notice here that there's a 25 degrees Celsius temperature on the room. There is 25 degrees Celsius in the room. So you will not notice that the temperature is in this direction. No, it is not going to have any direction. Okay.
Yeah.
Got it? Temperature is not going to have any direction. So it is only magnitude. Magnitude. Okay. Got it? Only magnitude is present here. So I will say here that scalar quantities is a quantities which is fully described by a magnitude only. It is described as just a single number. Okay, for example, scalar quantities example includes speed, volume, mass, time. Okay, or you can write a definition here also. Okay. Scalar quantities has magnitude and vector quantities has magnitude as well as direction. Example, temperature. You note it down, scalar quantities and vector quantity, definition of scalar and vector quantity. Example, temperature is a scalar quantity, mass is a scalar quantity, time is a scalar quantity. You can see. Do you think that time has any time direction? No. Time is time. That is 2 hours, 3 hours. It is not going to have any direction. Similarly, speed, distance does not have any direction. Okay, vector quantities has magnitude as well as direction. And they have both magnitude as well as direction. For example, you can say that, uh, for example, like we have example for this is weight, weight, weight. Here mass is a scalar, but weight is vector. Why? Because weight always act towards the center of the gravity, towards the center of the earth. So it always act towards the center. So it has direction. So weight is a vector quantity. Like similarly, velocity. Speed does not have any direction, but velocity has direction. When I say an object is moving with a 60 kilometer per hour, 60, an object is moving in the direction of 60 kilometer per hour in the direction of north. So now it has magnitude as well as direction. So this will be considered as velocity. Now speed has become velocity. Means when speed has direction, then it will become velocity. When mass has direction, it becomes weight. Okay, similarly, when distance has direction, for example, I travel a distance of 50 kilometer in the direction of north. Now it has become displacement. Now it will become displacement. Displacement. Okay. So this will become displacement. So velocity, weight, velocity, displacement are the example of vector quantities. So note it down.
Okay.
Note it has magnitude. Note it has magnitude as well as direction. Example. And then write this. Their example, write this 3.
Done, sir.
Done?
Yeah.
Okay. Now, what is going to happen here is that scalar quantities can be added or subtracted. Okay. Scalar quantities can be added or subtracted by adding them, by numerically adding them. For example, if you run 2 kilometer in this direction, 60 kilometer in this direction, then 40 kilometer in this direction, then 60 kilometer in this direction, 60 kilometer in this direction, and then 40 kilometer in this direction. So what is going? You just add all these and you will get the value of distance. Okay. For example, 2 kg, when added with 5 kg, you will get how much? 10 kg. 10 kg. 10 kg. Okay. Resultant will be 10 kg because it does not have any direction. But when the things have particular direction, for example, if you think that if you are moving and applying a force of 10 Newton in this direction, and then you apply a 5 Newton or 2 Newton force in this direction, then what is going to happen here is that you cannot add this. If you take this as positive direction, this direction as positive, then it is must that this direction will be taken as negative. So when you add these two, you will get 10 Newton plus minus of 2 Newton because 2 Newton is an opposite direction force. So the resultant force acting on it will be 8 Newton. You cannot add them like 2 plus 10, you will not get 12. Why? Because it is going to have opposite direction. If you write it like this, if a 10 Newton force is applied in this direction, and again 50 Newton force is applied in this direction, so 10 and 50, you will get 60. You will get 60 Newton. Why? Because the both are going in the same direction. Got it?
Yeah.
If you throw a ball upside and you take the velocity at 60 kilometer per hour, then the ball when when it will be coming back, then its velocity will be considered as minus of 60 kilometer per hour. Got it? Because its direction is changed. Okay, got it? But in displacement, it is sorry, in scalar quantity, we don't have the direction, so there is no plus minus sign. Okay. So let me please write You have noted?
Yes, sir.
Have you noted this? The distance, the difference between distance and displacement. Distance is a scalar quantity. Why? Displacement is a vector quantity. Okay, it can be positive, negative of zero. It can be positive, negative of zero. Got it? It can be positive and zero. It can never be negative. Negative. Displacement can never be negative. Can never be negative. Why? Because it does not have any case of direction negative. No? Means it does not have any. For example, why? How it can be negative? How it can be negative? For example, 2 Newton force is applied in this direction. 2 Newton force, and this in this direction, that is 10 Newton force is applied. The net resultant force, if you take this direction as positive, so this direction will be considered as negative. So 2 Newton plus minus of 10 Newton, you will get minus of 8 Newton. But here minus does not indicate, minus is indicating the direction. That minus, if there is minus sign, that it means that if you have chosen this as positive sign, then this 8 Newton force will be acting in the opposite direction of this one. Okay, negative sign indicate only direction, only direction. It indicate only direction. You understood? Got it? So note it down. It can't be smaller than displacement. Means distance can be equal to the displacement. For example, if an object travel A to B, okay, here, and that is 50 kilometers. So this is a straight line and their initial and final position are same. So here you see that if an object travels in a particular direction, so here the distance is say 50 kilometer and the displacement is also 50 kilometer. Okay, but it can never be greater than distance can never be displacement can never be greater than displacement. But here you see if an object is traveling like this 8 kilometer in this direction and then 6 kilometer in this direction, then its displacement will be 8 and 6 14. Sorry, no, not 14, it will be 10. It will be 10, and how it comes, that will be by using Pythagoras theorem. So 8 and 6. So here the distance is 14 kilometer, but the displacement is only 10 kilometer. So displacement can be equal to the displacement, but displacement can never be greater. Displacement can never be greater than distance. Distance will be always greater, or it can be equal. Okay. So it is smaller than the distance, but can't be greater than it. Got it? Got it, Rima? Please note it down. It is actual path. It's the shortest distance between initial and final position. So note down the distance, the difference.
Done, sir.
Done? Okay. Let's move further. Now let us start studying the graph. I have taught you the uniform and non-uniform motion.
Yes.
Now the graph of uniform and non-uniform motion. Let's study the graph of uniform and non-uniform motion. Okay. So have you seen this one? This graph?
Yeah.
So this is a position. Position means distance. Distance. Position means distance.
Yeah.
So distance time graph. If a line is parallel to time axis in distance time graph, so it means the position is constant at every time. So it means object is at rest. Okay, object is not moving. Okay, got it? You understood?
Yeah.
Here you see that the object's position is changing.
Yes.
Okay, and here you see that object position is also changing with time.
Yeah.
So if object position is changes with time, so it means it is in uniform. So it is in motion. Okay, it is in motion. Okay, so let me explain you that if you have distance time graph, if and the object is line is parallel to time axis, that means object is tell me object is moving or not moving. Distance, or you can say this is position time graph. So position is constant means if a line is parallel to time axis means its position is constant. Position is constant. Okay, if a line is straight time axis means all time the position is constant. Okay, you understood? An object is not moving. And if you have this is position or distance time graph, and the object is here you see. You see the object is in position time graph, it is if it is straight line like this, straight line, and object is in uniform motion. Uniform
Motion.
motion. Okay. And if it is position time graph, position or distance time graph, but the object is here you see that the object is like if I'm having this graph like this. So you see that the speed, the graph is curved. When the graph is curved, then object is showing non-uniform motion. Object is showing non-uniform. Wrote it down.
Done, sir.
Done?
Yeah.
Okay. Now in distance time graph, if the object, like you see that if you are having this graph like this is distance or position time graph. If you see that object is moving from here, so object is started from rest. If it is from static origin, an object is moving and it is also doing the uniform motion and it started from rest. Okay, the initial velocity is 0. And similarly, if it is distance, position or position time graph, here you see the object is, if graph is like this, so we say that object is not stationary. Means if object is moving but initial velocity is not 0. Okay, means it is not having initial velocity as 0, means it was not at the rest. Okay, so object is moving and initial velocity okay, don't try this, let it be. You will get confused, let it be. Okay, now I'm going to show you something here. Let's suppose if I'm saying that you know that speed is equals to distance upon time. Okay, and you know that speed into time is equals to distance. Okay, got it?
Yeah.
So note a point. In distance time graph, distance time graph, slope of line gives speed. And if it is instead of distance, if it is displacement, then it will give velocity. So it will be asked in the examination that what does the slope of line in distance time graph gives? So the slope of line in distance time graph gives velocity or speed. Okay.
Yeah.
Now moving to the next part.
So 1 second, let me write it.
Okay, I did. In distance / displacement time graph, slope of line gives speed / velocity.
Yeah, done, sir.
Then okay.
Yeah.
Now conversion of speed meter per second, speed into kilometer per hour. Okay, so if I'm saying speed in kilometer per hour, if you are having means some speed, any x speed, x kilometer per hour is equals to 5/18 times the meter per second. Okay, means if you multiply this speed, the same speed, for example, if you are having 72 kilometer per hour speed, and you want to convert it into meter per second. So for converting, you have to multiply the 72 kilometer per hour by 5/18. 20 meter per second. You understood?
Mm,
Understood?
no,
So
sir.
note it down.
I didn't understand, sir.
Okay, I'm going to explain. In order to convert kilometer per hour to meter per second. We multiply note it down, Rima. Note it down first.
Sorry,
Note it.
sir. Sorry,
Let it
sir.
be.
It has
Okay, notes no first. Okay, beta. So Rima, note it down that in order to convert kilometer per hour to meter per second, we multiply kilometer per hour by 5 by 18. First note it down and I'm going to explain it.
okay. Done, sir.
So generally the standard unit, like we have the, sometime the time is given in seconds, sometime the time is given in minutes, sometime the time is given in hours. But the standard unit of time is seconds. So if it is given in minutes, so you have to cut during when you are solving the numerical problem, then you have to convert it into seconds. Okay, if it is 1 minute is given, then you have to write 60 seconds during the calculation. Okay. Similarly, the speed can be in kilometer per hour, it can be in miles per hour, it can be other things. But the standard unit for speed is meter per second. What is meter per second? So sometimes the speed is given in kilometer per hour. We generally calculate, let's suppose a car is traveling with a speed of 90 kilometer per hour. So when you are just solving the numerical, you are not going to write this 90 kilometer per hour there. You have to convert this 90 kilometer per hour into meter per second. Into meter per second. So how will you convert this 90 kilometer per hour into meter per second? Just convert whatever is being written here, 90 multiplied by 5 by 18. So you will get 8, 9 2s are 18, 9 10s are, then 2 1s are, and then 2 5s are. It will be 25 meter per second. So if an object is traveling 90 kilometer per hour, it means that it is 25 meter per second. Okay.
Okay.
Okay. So please solve this question. This question, what would be the speed in meter per second and kilometer per hour? Both you have to tell me what is the speed if it travel 40 kilometer in 5 hours. It is 40 kilometer in 5 hours. So you know speed is equals to distance upon time. So if the distance is in kilometer and time is in hour, so speed will be kilometer per hour. So write 40 upon 5. Write 40 upon 5. It is equals to 8 kilometer per hour. You understood?
So
Chalo. Next.
how it comes 8 kilometer per hour.
Because we divide 5 8s are 40.
Oh yeah.
Okay, understood?
Yes.
Now you have to convert this 8 km per hour into meter per second. So if it is 8 km per hour and you have to convert it into meter per second, you have to multiply this 8 by 5 by 80. So you will get, when you divide it, 2, you will get 4, you will get 9. So it will be, now it cannot be further divided. So like 4 5 are 20 by 9 meter per second. That is 2 point something. Got it? Got it, Reva?
So
Okay. Do this question. No, let's hear if you have not done this. Wait a minute. Reva.
okay, sir.
No. जी सर. अरे वो मैसेज सर मैंने किया था, फिर मैंने देखा तो वो सही था. So done, Rima?
No, sir.
So please, let's do the next question. During the half of journey, travel by the speed and 40 km per hour. Next journey, half it. 40 km, calculate the average speed. Average speed we will do. Let's do the average speed question. Average speed. Now, what is average speed? Average speed. Average speed is equals to speed. If it is speed, then we will call it distance. So average speed is equals to total distance upon total time. Got it? What is average speed? Total distance upon
Total
every
time.
total distance upon total time. Okay. So here you see that is total distance upon total time. Now, if you are having, let's suppose, if you travel, let's suppose if I'm saying that what is the average speed calculated, if you travel 30 kilometer to this way, okay, and then 20 kilometer to this way, and then 40 kilometer to this way, okay, and you take the here, you take only 1 hour, then you take 0.5 hours, and then you take 2.5 hours. Okay. So how will you calculate the average speed? Total distance, that is 30 plus 20 plus 40, 30, 20, 50, then 40, 90. And you see that 1 plus 2.5, 3, 2.5 and 0.5, 3, 3 and 1, 4, 4. So that's 90 by 4 kilometer per hour. You understood?
Yeah.
You understood? This is a total distance upon total time. But sometimes the time is not given to us. Neither the distance is given. We have given the speed. Then what is going to happen here is, let me teach you this one. You given speed. For example, Rima, if I'm saying that an object is traveling 60 kilometer, an object reaches from point A to point B, that is 60 kilometer. The distance is 60 kilometer, and it takes 2 hours to reach from A to B. 2 hours to reach from A to B. And when this he is returning back, so the same distance 60, but he takes only 1 hour. Only 1 hour. And he was coming back. If I ask you that what is the average speed of that person? So average speed is equal to total distance upon total time.
3.
So total distance will be 60 for going, 60 for coming.
Yeah.
Average speed is equals to total distance on total time. That would be equal to what? Tell me. It will be equal to total distance is 60 for going and 60 for coming. 60 for
90.
120. And total time is 2 plus 1, 3. 2
Three.
hour for going and 1 hour for coming. That is 3. So total will be 6. That will be 40 kilometer per hour is its average speed. Got it?
Yeah.
But if I ask you, if I first note it down, first note this question: 60 kilometer for going, 60 for.
Yeah, then so.
Done.
Yeah.
The next one is, if suppose instead of distance, if it is given that an object travel from point A to point B with a speed of 40 kilometer per hour, and then he 40 kilometer per hour, and then he comes back with a speed of 20 kilometer per hour. Now the speed is given to us, not the distance. Then he will ask you that what is the average speed? What is
Six.
the average speed? So he is taking 40 kilometer. He is moving with a speed of 40 kilometer per hour and coming with a speed of 20 kilometer per hour. So what is the average speed of the whole journey?
60
Of
kilometers.
the, no, it is not 60. Whole journey. Average speed will be between 60 and 40. So at 20 and 40. Average means it cannot be greater than this one. Okay. So if I'm saying, let's suppose whenever this type of situation is given to us, we assume a distance with our mind. Okay. And we generally take the LCM of the speed. What is this LCM of 20 and 40? What is the LCM of 20 and 40?
20, 44.
Calculate it. LCM of 40 and 20. Or if I say that, what is that number which can be easily divisible by both 40 and 20? The number that can be easily divisible by both 40 and 20. Find the number that is both easily divisible by both 40 and 20.
2.
2.
Mm.
I'm not saying that. Find the number that is exactly divisible by both 40 and 60. Means you have 40 here and you have 20 here. What is that number which can easily cut this? That is called LCM. That is itself 40 here. And you cut it, you will get 41 the 40, and this you cut it, you will get 22 the 40. The 40 is that number that is easily divisible by both 40 and 20. So that is the LCM. Okay. Got it?
Yeah.
So if the average speed we need to calculate, so we need to calculate, we know the distance. So an object is moving with 60 kilometer, 40 kilometer per hour in the going speed. And when he's returning back, he is having the speed of 20 kilometer per hour. Okay.
Okay.
Got it?
Yeah.
Now, what I'm going to tell you here is that while solving this question, the question is calculate the average speed. Average speed. So what we need to do here is 40. Assume that the distance is 40. Assume from your mind, because that 40 distance is divisible by 40 and 20 both. Okay, so assume that distance is 40. The 40 is from here to going distance and 40 is for returning distance. That is 80 kilometer total.
Yeah.
And if suppose an object is moving from A to B and it is moving with a speed of 40 kilometer per hour and the distance is 40, so what time will it take? अगर कोई एक ऑब्जेक्ट 40 किलोमीटर ट्रेवल करता है और विद स्पीड ऑफ 40 किलोमीटर पर आवर, तो कितना टाइम लगेगा उसको? तो यू नो टाइम इज इक्वल्स टू डिस्टेंस अपॉन स्पीड। डिस्टेंस हमारे पास कितना है? हमने माना था 40 40 एंड स्पीड भी जानने वाली कितनी है? 40। तो व्हेन यू कट इट यू विल गेट 1 आवर। 1 घंटा लगेगा जाने में। जाने का टाइम कितना आ गया? 1 आवर प्लस आने का टाइम कितना होता है? सो अगर कोई एक ऑब्जेक्ट है जो 40 किलोमीटर जिसको ट्रेवल करना है, उसकी स्पीड है 20 किलोमीटर पर आवर, उसको 2 घंटे लगेंगे। तो जाने में क्योंकि 40 किलोमीटर पर आवर से जा रहा है और 40 ही किलोमीटर डिस्टेंस है, तो 1 घंटा। लेकिन आने में 40 किलोमीटर तो आना है, लेकिन स्पीड अब आधी हो गई, इट इज 20 किलोमीटर पर आवर, तब लगेंगे 2 घंटे। सो व्हाट इज टोटल डिस्टेंस? टोटल डिस्टेंस इज 40 प्लस 40, 40 जाने का 40 आने का, दैट इज 80 80 एंड द टोटल डिस्टेंस इज 1 घंटा जाने का, 2 घंटा वापस आने का, दैट इज 80/3। You can divide it or you will get 80/3. Okay, got it? So we will solve it. अभी तो नहीं समझा रहा मैं क्योंकि तुम्हें अभी अच्छे से समझ नहीं आया, तो अभी तुम्हें और प्रैक्टिस चाहिए। So let's do simple question. Let's have this velocity time graph. Velocity time graph. We were discussing the position time graph. Now this is the velocity time graph. So velocity time graph means if the velocity, this is velocity written here and this is the time axis. So if anything is parallel to this time axis, it means the thing which is written here is constant. So if I'm saying this is position time graph or this is distance time graph, distance time graph. So you know that this line is parallel to this time axis. So in distance time graph, remind, look at this. In distance time graph, if the line is parallel to time axis, then it is tell me
Not moving.
not moving. And here, if it is velocity related to time graph, if it is constant to parallel to time axis, then it is here not moving means distance is constant. Distance, what is written when you see such type of line parallel, that is parallel to time axis. So it means whatever written here is constant. So when it is written here distance on the y-axis, so
Okay.
it distance constant means object is not moving, distance is constant. That for example, if you are having a distance, you are sitting on your chair and the distance between the wall is not increasing, so it means you are not moving,
Yeah.
you are stationary. Similarly, if you are having velocity, if it is having now this similar graph, but it is velocity time graph, so it means you see that velocity is constant. Velocity is constant means now you see that this is the parallel line with time axis. So whatever written here is constant on the y-axis. So it is velocity time graph now. So this is velocity constant. Velocity is constant.
Mm.
Is constant. And when velocity is constant, it is uniform motion. So this is uniform motion. Uniform motion.
Much.
Okay. In distance time graph, uniform motion graph is like this. In distance time graph, the uniform motion graph is like this. But in velocity time graph, uniform motion is like this. Okay, note it down. Note it down.
Then, sir.
Done?
Yes, sir.
Okay. Let me show you the example. For example, Rima, you are having this is distance time graph. And if you are moving, having a graph that is made by a car A, another car moving with this one, B and C car. If I ask you which car is traveling faster, A, B, or C. So you see that this is 60 kilometer. Let's suppose this is 60 kilometer here. Let's suppose this is 40 kilometer here. This is 60 kilometer. This is 40 kilometer. And this is 20 kilometer. Meter, okay. And this is distance. And this is distance time graph, okay. And you notice here that this is 2 hours, this is 3 hours, and this is 5 hours. Okay. So if I ask you that, Rima, if a car is traveling 60 kilometer in 2 hours, another car is traveling just 40 kilometer in 3 hours, and the third car, yeah, the A car is traveling just 20 kilometer in 5 hours. So which one is faster?
60 kilometer.
Yes, it is faster because it's traveling more distances in shorter time. So car C is faster or fastest. Is fastest. Got it? Understood?
Yeah.
So when we have the graph like this in position time graph, position or distance, it may be, and you have a graph like this. Okay. So if you have A, B here, A, B, C, so more the angle with time axis, more will be the speed. So this is fastest. Fastest, and this one is slowest. Write down. Done?
No, sir.
Do it.
Then, sir.
Yeah.
Yeah.
Okay. Now calculate distance traveled in meters when an object is traveling with a speed of 60 kilometer per hour for 25 minutes, for 30 minutes, for 5 minutes. Okay, 5 minutes. Tell me, Rima.
Yes, I'm writing it.
Okay, let it convert the distance to from minutes to hour. It will be much easier for you. Okay. Hours. Okay, tell me the distance covered in meters.
So answer is 12.
That is speed is you need to calculate the distance. The distance is equals to speed into time. So you know that speed is 60 kilometer per hour. Time is 5 hours. So this is 300 kilometer. 6 5 30 and 0 300 kilometer. And 300 kilometer in meter can be converted by multiplying it by 1000. Okay.
Okay.
When you multiply by 1000, you will get 3 lakh meters. Okay. Got it?
Okay. Yeah.
So that's all, Rima. Okay, we'll discuss this one in the next class. Okay.
Okay. Thank you, sir. Bye.